kinematic equations are the set of equations that we would be utilizing when solving problems involving motion. So we have four. Some of the sources consider only three. Some consider as much as seven. Okay, but including the first two that we have, so we have the definition of velocity. So that's v is equal to delta x over delta t. Okay, or simply distance over time. Then we have acceleration, which is the rate of change in velocity over unit of time. Okay, we have as well average velocity. So average velocity is the one that I have been describing when, for example, you're speeding up or slowing down. If you're going to calculate for the rate of change in velocity, that would be acceleration. But if you're going to obtain the total or average velocity, so let's say from my previous example, you are walking at the rate of 10 meters per second and you suddenly saw a dog. So your new velocity is, let's say, 15 meters per second. So that would mean you're going to add your changes in velocity. And of course, since this is average, you're just going to divide it by 2. Okay, so let's say you have this plus this divided by 2. So these are the three what I call of them as the definition of speed, acceleration, and average velocity. But when it comes to kinematic equations, these are the derived forms coming from these three. So these four would be, okay, I'm going to write them down. So final velocity is equal to initial velocity plus acceleration times time. Then we have displacement is equal to the average velocity times time. Then we have displacement again is equal to a delta t squared over 2 plus v sub 0 delta t. Right? Then finally we have v is equal to square root of v sub 0 squared plus a delta x to a delta x. Okay? If you're interested, I'll be making a separate video of the derivation of these four. But for now, I want you to take a good look at the equations that we're going to use and some tips of how we're going to use them. So later I'll be showing you 4 examples using each one of these kinematic equations. Okay, but what you need to remember are the variables. So if you remember Gresa, okay, so we state the given, right? So for the given, we have all the variables here. So make sure that you can easily distinguish the variables. Okay, so for displacement, okay, our variable for that is usually in meters. So this is the SI unit for that. Okay, for time is in seconds. Okay, so if it's in other dimension of units, change it to seconds. Okay, you can refer to the review section for that, how to do that. So we have initial and final velocity. So initial velocity finally, acceleration has a unit of meter per second squared. Okay, so if you remember from the definition, which is here, so this is meter per second, so that would be, oh, I'm just going to show it to you. So that's meter per second, correct? Which is equal to meter per second times 1 over second. Okay, so this would be the result of that. So remember these units, okay? So they will be very helpful to you along the way. Anyway, so let's write this here. So you can have your and then A. Okay, so what this table would be helpful to you is when identifying what is the constant variable. So when you say constant variable, that would be the one that is not present on the problem. Okay, so you don't need to solve for it, you don't need to include it in the equation. Okay, so when, let's say, the problem said that assume the distance is constant, so that means you don't need, or I mean the displacement is constant, that means you don't need to involve delta x on your equation. Okay, so for our first one, so this would be the constant variable, so I'm going to mark this x, then the rest of this should be present on your equation. So as you're going to notice, all of those are present here. Alright, so for the next one, this is the equation that has a constant acceleration. Okay, it's easy to remember because the first part of it utilizes average velocity. Okay, so then of course the rest of this would be checked. Okay, for the third one, the constant for this is final velocity, I think. So alright, so you can see there's no final velocity here. Actually, it's more like not necessary. Okay, so that would be the one that's not included. So you can check x, you can check a. What's the next variable? You can check t. Okay, actually t appears twice. Then you have initial velocity. Then finally, for the last equation, this is called time independent equation. So that's how I remember it. This one is the acceleration independent equation. So these two are easier to remember for those names. Anyway, so here, time independent, it means time is not present. So you don't need time to solve for this equation. Then for the rest, those are present. Okay, you can have this table, of course, reserved since we are having online lesson, so it would be easier for you to actually look it up. We don't need to hide that. So just make sure that you understand how to utilize it fully. Alright, so there will be times that you're going to use two equations, so make sure that you understand what to use first, then what to use next, something like that. So on the next part, we're going to have 4 guided practice problems for you to follow through. So I'll be utilizing each of the kinematic equation and show you how it's used on problem solving. Alright?